most of you said 2, but usually it's as many as you can afford to pay for. What is the cartridge starter? It operates from a solid fuel that's ignited, and they use the gas from that instead of air. So they can spin the starter. Right, it's all self-contained system. You don't need any external system to use. So that means they don't have to have power. Disadvantage, well, expensive cartridges and erosion of the turbine, right? Because of that hot gas that they're using in the cartridge. So we do have a quick little clip of one working, so you can see what it looks like. Oops. Yeah. So here it is. So that one you can see the cartridge. You can see it shoot out all around the engine. So there's one other one that again a type of a cartridge starter, and we'll see if you know this. So called it a shotgun start. which uses a shotgun shell to start the engine. What kind of shell would I use for a shotgun start? All you hunters out there, that's pretty much all the gauges of shotgun shells. Guess you're not all awake yet. Only half of you can answer the question. Oh, must have woke up someone. So the popular choice was a 12 gauge shotgun shell, which it's not. So I'm not going to spoil it yet. We'll continue on. So they call it a Kaufman starter, and they use what they call a 4 gauge paper shell. Again, it fires into a starter assembly. It doesn't fire into the engine. Again, spins the starter up and then resets. So there's a little clip again to show you this process, which is pretty neat. So it shows you the actual old stock shells that they're using. Fairly large shell. So there you can see the difference in the shell sizing from your 12 gauge up to your 4 gauge. Again, a bigger shell. So hydraulic starter, it's pretty straightforward. Again, it's a hydraulic motor that's going to spin the turbine up to speed. Problem is you need a source of hydraulic pressure. And it could be a starter and then transferred to a pump. So let's test your your knowledge on which aircraft uses a hydraulic starter. You're probably going to have to open up Google again and search it. I know you have it open anyway. You have to stop playing your online game for 5 minutes. Only 50% are awake. Oh, they must have hit the Google search and figured it out. Slowly coming up. So someone made more work for me now. I'm going to have to go in and find out who picked the Cessna 172. 206. So 172 would have probably the electric starter. 206 is going to have a starter generator. 727. Anyone?
Isn't that an air starter, Brad?
It could be, yeah. Does anyone know what the CH-47 is?
It's the Chinook.
Yeah, so the Boeing Chinook, and that's the one that actually uses hydraulic starters, if you didn't know. So the Chinook has the APU starter and pump. So there it is. So basically, it starts the APU and then turns it into a pump. And then the main starter is just a hydraulic motor. So it shows you the two different, again, see the same mounting style as the others that we've seen already. Again, the opening with it, the flange with the lock. So it spins on. So there you can see two main engines on the starter engines, and then the APUs up top, starter APU pump. I believe it's got the hydraulic winch motor, so most stuff is hydraulic. So looking at the air impingement starter, so if the aircraft doesn't have a starter installed, what they do is they basically force air into the turbine blades We got to get air from an external source. And again, using a nozzle to direct the air and spin the turbine.
Fact: McDonald's Egg McMuffin is the McMuffin of McMuffin sandwiches, made with a freshly cracked egg.
Hey everybody, welcome to Jet City. It's been a couple of weeks now, so it's about time to make another video in the list, the ever-growing list of the biggest mistakes people make when trying to understand jet engines. So this one will be number 3. It's not exactly in alphabetical or numeric order, but it's close. I can't say this is the 3rd most common mistake, but it's up there in the top several. Okay, and that misunderstanding is what causes the compression of the air in the compressor. So we've got a book here, some diagrams, a real jet engine that we're building on Patreon. You can check out if you want. We got the whiteboard that we might use if I can draw something. But basically, I'm not going to say what the percentage is because I don't know, but a lot of people say, oh, I get it. It's because of the shape of the compressor that the air gets rammed in there and it gets squeezed down. Let me show you what I mean. And it's completely wrong. Okay, what we've got here is a nice color diagram that I copied off of the internet. And then I took it to the local, I think it was Staples. I paid 45 cents to get it enlarged and laminated, and here we are. So this file is out there. If you look at J79 engine airflow, it'll be right there, and you can blow this thing up to far larger than I have it here. But I want you to take a notice, a looky-loo at this. The white pieces are the compressor blades and stators. They haven't distinguished between rotating and stationary. But the blue is the air, and you can see that the pathway for the gas, the air that gets taken in the front, goes through this passageway and comes out there. Okay, so how do we explain this? We're going to take a look at this book, but as an aside, before we get to the book, we're going to, well, actually, when we look at the book, I'll show you what I mean. But it's always important to read more than one source. If this was your textbook, and this was my textbook when I was in jet school, yes, it was.
The high ground. There is no substitute. The high ground is where vulnerability...
Okay, there's a lot going on this page, but this is the most important part. It's a pictorial part that I want to pay attention to. If you freeze and read this, you may or may not have your confusion decreased. It may increase it, so do that at your own risk. But I want to show this shape here. This is the inlet of a compressor. We've got the tapering down of the gas path. And these little blocks, or cubes, or cubic forms, they are imaginary blocks of air. So as the air enters, it's at a certain density or pressure. And as it leaves, it's at a higher density, higher pressure. And because the pressure is increased, the volume is lowered. We'll get to an equation in a second that's very, very simple. It'll explain this. But anyway, so the air, this is a big piece that weighs a certain amount, and as it gets squeezed down, it still weighs the same. It's the same amount of air, but it's been squished into a smaller piece. So now everything that goes in this end comes out that end, and we want to keep the speed up because, as is stated in other places in the book, that the jet engine works by accelerating air. So by accelerating air, you don't really want to slow it down. You want to keep the velocity up if possible. So if you've got a smaller number of pieces, or the same number of pieces that are smaller, and you've got to keep them going through the duct at the same speed, you need the duct to get smaller. So that's the one in, one out relationship, and the fact that air is more dense when it's being compressed, because that's what compression means. You squeeze the same amount of air into a smaller space. Okay, hang on. Okay, I looked up on the internet thingy that air has a density of 0.0765 pounds per cubic foot. So that's how much 1 cubic foot of air weighs. So if we divide 1 over 0.0765, we get how many cubic feet is there in 1 pound of air? So 1 pound of air is roughly 13 cubic feet. So 13 cubic feet of air is 1 pound. So we've got our compressor. Oh, I should make the outer, yes, this is an important thing as well. The outer diameter of the compressor gas path is usually pretty straight, and the inner diameter, the inner diameter of the space that isn't the compression gas path, it increases. So it looks something like that. So we have 13 cubic feet of air here, 13 for 1 pound. So the air comes in the front and it comes out the back. Whatever goes in the front has to go out the back. So 1 pound of air at 13 cubic feet comes in the front, but we compress it 10 times. 10 times. So that means that it's going to be 1.3 cubic feet. 1.3. It's going to be 1 pound of air going in there, 1 pound of air coming out the back. It has to, whatever goes in has to come out. It can't disappear. It can't dissolve. And if this is a perfect compressor, we're not heating it up. Wouldn't that be great? Nothing's perfect, but for the model, it is, that's what we're going to go with. So 10 times the compression, 10 times the pressure, 1/10 the volume. And then again, that's our P1, V1. So 13 cubic feet at 1 atmosphere. 13 times 1 equals 1, right? Yes. And 1.3 times 10 atmospheres. So 13 equals 13. So P1, V1, I got the symbols backwards. So it'll be V1 volume times pressure, 13 times 1, equals volume times pressure, 1.3 times 10. So 13 equals 13. Does 13 equal 13? I hope so. Good. So the same amount of air is going in the front as coming out the back, but if we were to if the pathway was straight, a straight tube, then the air would slow down to 1/10 the speed, and we don't want that. We want to keep the speed the same. So if it comes in at 100 miles an hour, it wants to leave at 100 miles an hour. That would be a nice situation. Your compressor is just compressing the air, not changing anything else about it, and there you go. Okay, why is it so easy to make the mistake of thinking that the compression of the air is because of the funnel-shaped decreasing area, and the air gets rammed into that? That's a mistake that is easily made when you're a little kid and you see the rain dripping off of a roof. Okay? Rain's dripping off. Also works when you're plowing gravel with a grader. Anyway, these things, if you have the rain dripping down off the edge of a roof that doesn't have a gutter, okay, and you place a couple of pieces of plywood and a bucket, then the rain comes down, it hits this, all falls into here, and it all goes into the bucket. So you're increasing the density of the apparent particles of rain. It's a diagram that seems to make sense. You're collecting it and funneling it, and you're increasing the amount of water here as opposed to here, right? Also, if you're plowing a road with a grader, and this is all gravel, then you can concentrate the gravel to one side with a big blade. And the important thing to remember is air is not gravel and air is not rain. Okay? But I think these two images that we see when we're kids or even now when we're adults, you see them and they seem to make sense. And so it doesn't make sense. It doesn't make sense when you have it doesn't seem to make sense that the pressure here is higher than the pressure here. How does that make sense? Well, you've got pressure and speed. So the speed here is whatever. Speed is 1. Need a better pen. Speed is 1. And here the speed is 4.
So I don't know where the air starter went in on, but maybe you learned some more about turbines that you didn't know. So that was just a little clip of some issues when they're starting. I don't think the helicopter is supposed to have an afterburner. You can see how hot it got. So we have a little story time. So there's always that one student. Every year seems to be. They have to disagree with me. And we need to have arguments. So in a quiz, I stated that aircraft start on the left mag for their starting systems, which we've all gone over. This year, not many argued. Well, they disagreed. They said that aircraft start on the right mag. So the solution was, I said, prove it to me. Show me proof. So what they did is did their research, and they said that all P-51 Mustangs start on the right mag. So I said, really? Here's P-51 Mustang. Sure he's turning on the right mag. And for some reason, this seems to be a phenomenon. These students seem to drive Ford vehicles.
Well, you know what, Brad? That's pretty interesting how you start a turbine on a magneto.
There you go. Yeah. So just be careful when you state, all things happen.
Well, I would probably counteract that. You know what? I commend the student for at least challenging you. But I would also say that helicopter was probably a problem.
Yeah, I'm not sure how many inspections they were probably going to have to be doing after that.
Yeah, I've seen lots of the turbines start. I can remember one time the boys started up the Hawker Siddeley 748, and I swear there was a 20-foot flame out behind it. I've seen lots of days that we started the old Convair on those cold -31 days, and there'd be a 6 or 10-foot flame out behind it.
The old MU2 used to get some flames too with Alex. So if you're interested, I did put links to those videos for you. So you can go back and see them if you want. I will probably update it because I don't know why YouTube keeps messing with me, but they changed the links. So I'll probably update the one on D2L so you can get to them. I think most of them work, as far as I know. So they're going to be, I guess, tomorrow, the turbine quiz will open. So I'm going to ask you some questions about those videos. If you don't remember, that's why the links are there. You can go back and look at them. In power plants, there's some information that you're going to ask. So make sure you know where your power plants book is. Holding up the table, maybe. The air turbine diagram, I'm going to ask you some questions about that. And then most of the stuff should be right from the PowerPoint. There is some hints. So if you're stuck, look at the bottom of the quiz and the hints are there. So you can open up the hints to help you. You have 2 other quizzes that are going to close tomorrow night at midnight. Don't forget those. Right? I don't want to be trying to remind everyone about your quizzes. Yes. If you look, I think the power distribution has the page numbers out of the book as well as the PowerPoint. And then there is stuff on lighting in your general as well. So pretty much you have time right now to go and get them done. The only thing I was going to mention is when we did our latching circuit, everyone's graciously working on that, but I'm going to let you know that there is one mistake in there. And I'm sure once one person finds it, it'll spread. It'd just be when you find it. So there's a wiring error in there somewhere. So as you come across this error, you can fix it. Again, how you want to fix it is up to you, but there is one error that's going to cause you a problem. Just for fun. Any questions? No questions? So I'll let you go. You can go and do your quizzes. You can go back to sleep. But remember, there's 2 that are closing tomorrow, and then your turbines is opening up after that. All right.
One of them is actually closing tonight.
Is it closing tonight?
Yeah, one of them closes tonight, the other closes tomorrow.
Okay, sorry. One closes tonight. That would probably be the distribution.
Yep.
Yeah, so it closes tonight. So go do that now.
I already did.
Good. I'm going to have to go on D2L and pick out names and yell at you. Hope not.